Next, we're going to look at extrema, and these are just the biggest and smallest values on an interval. And so the question is, how do we find these values? So to start off, extrema are the biggest or the smallest values on a given range. So between this point and that point, what's the biggest, what's the smallest? The maximum is the largest value, like you'd expect from English, and the minimum is the smallest value. Again, like you'd expect from conventional English here. But there are two types of extrema that we can talk about. And I'll point out that because of the weird Latin, the plural for maximum is maxima, and the plural for minimum is minima, and the plural for extreme is extrema. It's a weird, unfortunate Latin thing that's not like conventional standard. Well, it's not like the rest of most of English. But there's two types of extrema. And the first is the local extrema. And these are compared to the immediate neighbors. So if you're the tallest point of the points right around you, so something like this point right here would be a local maximum because it's bigger than all the points to its left, it's bigger than all the points just to its right. But you can see that it might not be the biggest point on the entire function because there's, all of these points here are larger. So those are local extrema. And then global or absolute extrema are compared to the entire range. So if it's bigger than all the other numbers on the interval or on the range, domain. That should be domain. It's bigger than all the other numbers on the domain. I guess range works, but if you're looking across the domain, find the biggest value, and that's your global or absolute maxima. So the number of extrema. Things to note here. For global extrema, it may have both max and min, just one, or neither. So you can have neither, just one, or both. And some examples of this, something like, let's say, something like this has neither a global minimum or maximum because the endpoints aren't defined, so you can always get a smaller number. Something like this out to infinity may have just a global maximum, but no minimum because these continue out to infinity. And something, say, like this might have just a minimum and no maximum, kind of the inverse of what we saw to the left. So you can have one, both, or neither. I just want to point that out. And this is for global. The extreme value theorem, though, says for a continuous function on a closed interval, make sure I'm not missing anything. Yeah, so if it's closed and bounded, it has an absolute max and min. So this is differentiating from what we saw before, where this this interval is not closed because it doesn't include the endpoints, right? So the extreme values theorem says if it is on a closed interval, then by having those endpoints, there has to be one of those points that's the biggest and one of those points that's the smallest. So if both of your endpoints are defined, there has to be some number or some numbers along there that's the biggest number, and there has to be some number or some numbers along there that's the smallest. So all the examples I showed on the previous slide where they're missing either a maximum or a minimum, that's because they're not closed or bounded. And that's what we care about here, is that it's closed and technically bounded. So that's the idea behind Extrema, and we'll talk a little bit about some other points in a minute.